Hey, what's going on? All right, so I'm gonna try to record myself doing the January challenge, and I'm also recording myself with a obviously I'm doing this live. I haven't practiced or anything, so I'm also recording myself with like my webcam, but it looks weird because my camera is below me on my laptop, and I'm looking at a computer screen, a monitor. So it look a little weird, but I don't have a camera right now that I can set up, so it won't look like this. But I figure it's better to at least have a webcam on, I guess. Um, so what my goal is to I'm gonna try to record myself solving every day of the January challenge. Um, I've tried this before, but I haven't been consistent. I've only done like a couple of days in that month, and and for this one, what I'm gonna do is, yeah, so I'm just gonna get straight into it. But yeah, my goal is basically I'm gonna record myself doing all 31 days. Hopefully, that'll keep me motivated to do them. And um, I'm hoping to get a lot of practice from doing this and learn some things. And I'm gonna be doing it in Go language. So, and I'm still a bit new with Go language, so we'll see how that works out. This is basically gonna be you're gonna be seeing how I would solve these problems as someone who has like 4 years of experience in software engineering and like only a little over a year of experience with actual programming. The first time I ever programmed was a year and 4 months ago. So you're seeing basically a beginner still. All right, so here's the problem. Check array formation through concatenation. You're given an array of distinct integers, okay, an array of integer arrays pieces, where the integers and pieces are distinct. Your goal is to form an array by concatenating the arrays in pieces in any order. However, you are not allowed to reorder the integers in each array. Pieces I. Return true if it is possible to form the array from pieces. Otherwise, return false. Okay. Okay, I see. So this is my piece, and it's asking, can I form this array? I can. Like it only has one piece, and I can make the array from it. I have these pieces. Can I make this array from these pieces? Yeah, because I can just concatenate the 15 and then concatenate the 18 on it, or concatenate 15 to 18. This one's impossible because I have one piece. I can't make it in this order. It's not the same thing. Cannot reorder it. This one is like this, and then we have the pieces. So okay, we'll make this one. I'll take the 91, then I'll take the 4 and 64 and concatenate it to the 91, and then concatenate the 78 on that. So here they say concatenate 91, then 464, then 78. Okay, and this one's false as well because the numbers don't even match. So how would I do this? I'm gonna look at some constraints. The constraints are, so array length is less than or equal to 100. So the array is not going to be that long. So I should be able to do this in O of n squared time complexity, because 100 times 100 is only like 10,000. So that's not that many iterations. It should be done real quick. And it looks like the pieces only have to be less than that. Okay, so I think let me think about this for a minute. So this is how I would approach this. So a brute force algorithm would be, let's say, I have this array here. So I have the array, and then I have pieces. I guess brute force would be have like a pointer on my array. So I guess oops. Let's see here. let's think for a minute about this. I think this is an easy problem, so hope I don't have any trouble. So let's say we have an array. Let's do one that's kind of interesting, like 91, 4, 64, and then 78. And then we have pieces, which are like, I'm not going to draw pieces, but I'm just going to say I'll have a pointer here to the 91. And it kind of makes sense. So like this pointer could be like any good thing. Like, I don't know, I guess I is a good pointer value thing. So I'll have it pointing to 91, and basically I'll iterate through my pieces. So it'll be like a double for loop, a for and a for loop. Um, and then through pieces, I'll basically check like the first number in each piece, because each piece contains like they're like slices in terms of Go language, or arrays, whatever you want to call them. But I think they're slices. And so it'll contain these slices, and I always want to look at the first number and see if it's equal to this. If so, I want to use it. But at the same time, not exactly, because what if numbers repeat? Well, they don't. You're given a distinct integer array. And also the integers and pieces are distinct. So the fact that they're distinct is making this a little easier. So I just need to check the first number and see that they're equal, and then say use that one. And then iterate through this piece and make sure that it iterate my pointer according to the length of the piece. So like if we have the 91, we would say, okay, 91 matches, move my pointer to here, and it matches. And then we have the 4 and the 6, 4, the 4 and the 6, 4, and we're like, okay, well, if you see the 4, so then we're going to do that one. Move my pointer 2 places, see the 64 matches, move it. If the 64 did not match, like if it was another, like 68, then we would stop and return like false or whatever. Yeah, so this algorithm would be about O of n squared, I'd say. I mean, it's just basically 2 for loops. It's kind of simple. I guess let's just get this solution. That's from something earlier. Yeah, let's just get this solution right now, and then maybe I'll think about optimizing it. Okay, so here we are. So I said I was gonna need an index, and then I'm gonna need to for loop through the array. Oh, you know what? Let's call it pointer, because I don't wanna. And then I want to, and then I always do this because I might need this. And then I'll say for in the range of the array, or, well, it's more like for, oh, you know what? For I equals 0, I less than n, I plus plus, let's do that. And then I won't need this. This is my pointer. Okay. Let's suppose we make it to the end. I guess we'll return true. Now, we want to get our current number, so we say current num will be equal to array I, and then you know what? Let's define I out here, so I can and then let's just say we for loop as long as I is less than n, and then create my current number. Yeah, and let's say for define and length of pieces. I also need this. And so I'm trying to think what for loop I want to do. I think this will work fine. Well, so this is something I'm not too sure about in Go. I don't know if there is a, I don't know if this is the best way to for loop through these a lot of times. I guess one way to for loop through would be, okay, J++, okay, and if pieces J0 occur none, and then I want to move my pointer. Well, I need another for loop. I need a for loop through pieces and move my pointer forward. So, or wait, if it's equal to current we'll do for k equal to 0 as long as k is less than p, as in length of pieces j 0 and do k plus, and then do if pieces j at k does not equal to current num, then return false. But let's see, what am I trying to do here? But normally we want to, let's see, normally we want to move forward. So normally we would do, I need to increment I forward. And so first off, we know that the first one's equal, so like, don't really need to start there. We can just start here. And we could, well, no, let's just start at 0, and then we see that they're equal, and then we increment I, and then we compare it to an array of I instead. Okay. And we increment I, so we go to the next one, and so on and so on. So then we don't need that. Instead, we're looking for array I. So this will work. For some reason, they're not equal. I'll break it, but otherwise, it'll go to that piece, move my pointer forward on my array, and move the pointer forward on pieces. And then, let's see, at the end of this, let's suppose no pieces match. Oh, also, if this is case, if a piece match, we don't want to continue iterating through J, so we just break. Make sure I did this right. Yeah, okay, this is in my if statement for pieces. Now this is in my this is for my for loop for J. If we don't find any matches, kind of need to know that. One way to do this is to create some type of Boolean check. But I'm trying to think I'm trying to remember if there's another way to do it. I'll give it some thought, but like normally I would just do, I guess, a Boolean check. What else? What other way would I do this? um, hmm. Another way to check is if I doesn't move forward at all, like if it doesn't move forward even a bit, then that means that we are. That means basically we are done already because we didn't find anything. Like the pointer has to move forward. So another way to check would be to set some cur equal to I, and then at the end, if we really do j, and we didn't find a match, then if cur is still equal to I, return false. Oops. Like that. Alright, run that code. Maybe I missed an edge case here or there. Okay, that's right. I forgot to define it. I have to initialize it. Invalid argument. That's true. Should just be that piece. I guess I'll do a couple of test cases. See what I get. This one's supposed to be false. I think this will be enough. Let's see what we get. Okay, this is wrong. This one. So 91, it should, so it's going to go to 91, and then it's going to go iterate through j, and it's going to find this piece here. It's going to say for this and this length, so it's going to increment I by 1. Break is not equal, it'll continue to the next one, which is 4. It'll look through here, find 4. Move it forward 1 time, and a second time. And then it'll go to the 78th. Darn it. I don't see the mistake for some reason. Hmm. 0. Okay. Did I mess up something here with the... I is equal to 0. Yeah. Yeah, this is working, right? Okay. What is this empty space for? Oh, because of this. There's another empty spot right here. Is it right? I'm gonna try something different with the string. My voice is dead right now. Okay, so that didn't work. Let's maybe print out this. Oh, this is in the wrong spot. Whoops. It should be down here. It shouldn't be in the for loop with the J index. Okay, that was the problem. I should be using VS Code, shouldn't I? Hold on. Probably it'll work now. Alright, it's accepted. Okay, so cool. So I made a little mistake. I think, yeah, brute force. How would you optimize this to be better at O of n squared? I mean, maybe you could do O log n log n. I'm trying to think how would you do that? Um, my voice is really tired. I'm a little sick, so it's hard for me to have a little trouble doing this. But let me think. Hmm. So another way maybe to do this would be, because let's think, if I'm trying to do it in a one pass or something, I could, I could do a binary search, but I don't think anything's sorted here. So like binary search on pieces. Well, okay, yeah, I do know how to do it in O and login. Okay. Um, that's not hard. So we could optimize it a little bit. So we could do it in this, I proclaim. And actually, it's not exactly that, but it's the one pass through the length of the array, and then it will go through log the length of pieces. So basically, I'm thinking of doing so I guess if I call these n and I call this m, I can write this as O in log m. So yeah, the reason why I could do this is all I would have to do is sort pieces, and then I just do a binary search on pieces and see if there's a value that matches. And I would find it, and then I would have to just iterate through pieces to make sure every number matches in it. I don't think it's guaranteed that that every value in pieces will match. Like I'm thinking you might have an array like X, Z, and maybe like this matches the X, but then the next doesn't match. So you need to check, I think, each one. So let's try to optimize our code. This will be a little bit of a speed up. Of course, um, when you're iterating through the length of the piece, though, that only happens once, so that's not really going to contribute too much to the time complexity. So yeah, it should be faster. I'm going to do this. I'm going to compare speed when I do this. So let's look at the speed for this one. Well, it's already super fast. See, that's why there's not really any reason to optimize this. So maybe I'm not going to bother doing it because it's just a small example. But yeah, way to improve it would be to do a binary search. But I might do it. Actually, I'm going to do it because I feel like I need to practice binary search in Go anyways. So just do Rome real quick. Okay. Also, I want to look at the hints. you only get note that you can only get the piece every. What do you mean by naively? Because I could binary search it. I don't get that. Maybe they mean naively in terms of you have to check through the piece. I'm gonna go to discussion actually real quick. Oh, you can go do O of N with the dictionary. Oh, oops. Oh yeah. Alright, good thing. Okay, good thing. This is my first problem. I'm just warming up. Okay, yeah. I could do this in one pass. With a hash map or it's a map in here. Okay. So let's see. So if I'm gonna use a map, how would I do this? I would say for pieces, I would just keep track of each of the first integers for each piece in a map. And I'll map it. So I'll map the piece value. So uh, x, and I'll map it to the index. So like 91 maps to index 0, and 4 maps to index 1, and 78 maps to index 2 if you have pieces like this 91, 4, 64, and you have 78. And then it's just going to be when you iterate through here, you create the map in O of, so we can do this in O of n time complexity, where n is the length of the array, and then we just keep a pointer. We'll keep a pointer. We'll say, okay, we're at 91. Or let's say our ant thing is 78, 4, 6, 4, and 91. And then my pointer's here, and I say, okay, cool. I check my hash map. I say, oh, here it is. It's at index 2. I move my pointer forward. I go to that index in pieces and I iterate through it in my pointer. So here at 4 it says go to this index, so I go here. I create like a temporary pointer to this one, and then I move through here. These are equal, so I move forward, and then I check the 91s, and I'm done. Okay. I use J right now because I'm gonna use J right now because I use I later. Right. Okay. So then J. Oh yeah. So as long as J is less than uh um, as long as J is less than, okay, this is kind of weird, but yeah, as long as J is less than M forward. Hmm? Huh? What's going on? Yeah. Oh, I got it backwards. See, I lack confidence because I'm still a beginner with Go. Alright, it worked. 0 meters milliseconds, but it's kind of hard to tell if it's any faster. See if I can figure out a way to compare the speeds. But overall, how long did that take me? It probably took me a long time. Dang, it took me 35 minutes to solve that. Oh boy. Yeah, there's definitely going to be a day where it's going to take me an hour or two to solve a hard problem. Shit. There it is. Alright, I think I've solved this before. I forgot about it. Okay. Apparently I solved this a couple months ago. I wonder how I did it then. Huh, did it in Golang back then. That had to be right when I started using Golang on LeetCode though. That'd be one of the first problems I did. Because I just started using it like 2 months ago. And I had used a map. Wow, I completely forgot that I did this. And yeah, I was preferring to use this type of for loop. I did this index found. Oh right. Oh, you can do it this way, but I feel like this is less readable, so that's why I don't like doing this anymore. Yeah, you can just put the Boolean statement here, and then say if it's found, then iterate through pieces. Oh, actually, this is a cleaner iterative method. I should have done that this time. And then return false, otherwise just increment. So basically, it's the same code. I think I should have done this type of for loop because it just looks better. And this is also similar. I did the range for loop, and I did npmap. And I declared my variable by saying var. I don't really do that anymore. I just use the colons. Okay. Oh, it took me to. Oh, did it? Oh, I did this in a contest. Oh, that's when I did it. Oh yeah, this was in a contest not long ago. How did I do in that contest? Probably pretty bad. Okay, let's just go back here. Apparently, okay. I guess I can't really compare the runtimes because they're all 0 milliseconds, so it's just too small. So okay, yeah, that's it. That's day one. Um, and yeah, using ranges is a little more clean than using these for loops. Sometimes these for loops are better, but it depends. I do like the range for loop. Um, but yeah, so good problem. I'll come back for day two and do that problem.